In this session, let us understand the concept of hypothesis testing. Hypothesis testing is closely related to what was discussed in another machine learning basic series video, population versus sample. Okay, the two are very related. Why the two are related? We saw in this in the video on population versus sample that due to constraints of time, cost and practicality and availability of data, we don't collect data from the entire population that is relevant to the study. Instead, we take only a sample and we will ensure representativeness and randomness. Okay, representativeness and randomness will be ensured in the sample because these two will ensure a higher forecast accuracy, right? Then where this concept of hypothesis testing comes? Okay, it comes when we try to draw inference for the sample. Sorry, when we try to draw inference for the population based on the inference of the sample. Okay, I draw an inference by analyzing the sample data set. I draw an inference based on the output of the machine learning models that uses sample data. Okay, I have this inference that is based solely on the sample data set. However, I use that inference to draw inferences or conclusion for the entire population. That is where the concept of hypothesis testing comes, right? I have drawn some outcome for the sample. I am now extrapolating it for the population. Remember the opinion poll example, right? Out of say 1.3 billion population, in India, okay, sample the feedback is taken only from very few number of electorates, right? So less than 0.5% of electorates feedback is taken. An inference that party A is going to win is being made. Okay. Now, the inference that party A will win, that is based on 0.5% of the electorate, is now extrapolated to this population. Are you getting this? So that is where the concept of hypothesis testing comes. So when I extrapolate it, I say with certain confidence level, right? I say with certain confidence level. What is the ideal confidence level that we want? Is it 50%? Is it 80%? Is it 90%? What level of confidence you want? In the world of business, we want at least 95% confidence level. Okay. If you are having a healthcare, what level of confidence do you want? I want a confidence of 99%. This is also known as alpha. Okay. In statistical terms, the confidence level is referred to as alpha value. Okay. We say that this is 0.05 and stuff like that. Do you understand the concept of hypothesis testing? I have drawn some inference about the sample. I am now extrapolating it for the population. So I say that with certain confidence because it is healthcare, right? I want a higher confidence level. I don't want a lower confidence level, right? You may say that why can't I go with 80% confidence level? Then the person who is funding your study will turn around and ask, why should I waste my time on this machine learning exercise? Yeah, you are going to learn, right? But how is it useful for the organization that is spending time, money and resources on this? Right? Do you understand? That is where the concept of confidence level comes in. Okay. For this, I use what is known as H0 and HA, null hypothesis and alternate hypothesis. This is known as null and this is known as alternate hypothesis. Okay. HA and H naught. What I want to prove is the alternate hypothesis. What I want to prove. Okay. What I want to prove is my alternate hypothesis. And the opposite of what I want to prove is my null hypothesis. Okay. In the world of hypothesis, we either accept or reject the null hypothesis. Okay. When we reject null hypothesis, what happens? We are going ahead with alternate hypothesis, right? So this is an indirect way of doing. That is how we work in the world of hypothesis testing. Why, you may ask? Let's say I have accepted an hypothesis for 10,000 times. And then on the 10,000 first time, I reject the hypothesis. It means I am rejecting the hypothesis, right? That means the hypothesis is rejected. Even if it is rejected once, it means the hypothesis is rejected. Though I have accepted the hypothesis in the past, which is why we take the indirect route to prove. We reject the null hypothesis, and in rejecting the null, we accept the alternate. Are you getting this? In rejecting the null, we accept the alternate. Why we go for the indirect route is this, what I just explained, right? So hypothesis testing is basically to ensure whatever inference you have drawn on the sample, that can be extended to the population with a certain level of confidence, right? You go for population, you don't go for the entire population data because of practical constraints like time, cost, and other things. You only work on a certain sample. It always happens, please note, only in academic situations that people get to work on the population sample, because the population sample is very small. In real life scenario, you always work on sample only, right? In fact, apart from the considerations of time, cost, sometimes when data is exported from one database to another, right? When a data is exported from, say, a database to a data warehouse, and then you take it for your machine learning analysis, the data can even get corrupted, right? Data may even be lost. So you never get to work on the entire population. You get to work on only the sample. So the concept that was discussed in the sample versus population video and the concept of hypothesis testing, confidence level, is very much applicable in real world. So please note this, right? We are doing all of this to ensure my accuracy is high and the inference that I draw for the entire population based on the inference of the sample is reliable, right?